What is the distance to the moon? What would be the best way to measure the distance from Earth to the moon? Are you thinking miles? Inches? Perhaps light years? $100,000 kilometers? That's about 62,000 miles. 200,000 kilometers? That's about 125,000 miles. Keep going. The moon is about 238,855 miles from Earth. Though that distance varies from 225,623 to 252,088 miles as the moon orbits around the Earth, to help make sense of such an astronomical number, think of it this way. If there were a road from Earth to the moon and someone drove a car on that road nonstop at 60 miles per hour, they finally get to the moon after about 165 days. If they stopped to eat meals and sleep each night, it would take nearly a full year to get there. Yet, in 1969, NASA sent a piloted mission to the moon that arrived in a little more than 3 days. The calculations and mathematics needed to make this journey were immense, and NASA relied on some brilliant mathematical minds to make it happen. Until 1958, NASA was known as the National Advisory Committee for Aeronautics, or NACA. NACA began to hire women in 1922, but it wasn't until 1935 that women began to work as human computers. When World War II began in 1939, many of the men who worked at NACA were sent overseas. NACA began to recruit more female mathematicians to fill their places, including African American women.
Early on, computer programming was considered women's work, and most programming was done with a pencil and paper before being run through the machine. There was a woman, Stephanie Shirley, who started her own computer programming company so she could work from home and they could have flexible hours that allowed women to take care of children and families. One of these workers, Ann Muffet, programmed the black box flight recorder for the Concorde. You can see her programming at her kitchen table while her young daughter looks on.
Katherine G. Johnson, born 1918 to 2020, was one such scholar. As a child, Johnson excelled in mathematics. She graduated high school when she was only 14 years old and had an interest in astronomy, which is the study of stars, planets, and other objects in our outer space. Johnson began working in mathematical calculations in 1953. She was so good at this work that sometimes she was asked to double-check calculations of electronic computers. Yes, she was asked to check the calculations of electronic computers. Johnson was the very first African American, male or female, to work with the American Space Task Group. Her calculations were crucial for allowing NASA to safely send and return the first American astronaut who went to space in 1961 and the first humans who went to the moon in 1969. In 2016, NASA renamed a building in the Langley Research Center the Katherine G. Johnson Computational Research Facility in Johnson's honor.
Dorothy Vaughan, born 1910 and died 2008. Another mathematician and expert in computer programming, was essential in leading NASA to the new age of electronic computing. She joined the Langley Memorial Aeronautical Laboratory in 1943 and later became NASA's first African American manager. Vaughan's work played a key role in helping NASA launch satellites into Earth's orbit through the 1960s and beyond. Mary W. Jackson, born 1921, joined NACA in 1951 and was the first female African-American aeronautical engineer in the United States. Jackson managed the Langley Federal Women's Program, where she hired and promoted more female scientists and mathematicians. In June 2020, NASA renamed its headquarters in Washington, D.C., the Mary W. Jackson NASA Headquarters. In 2019, Vaughn, Jackson, and Johnson were honored with the Hidden Figures Congressional Gold Medal Act in recognition for their service as mathematicians, engineers, and human computers. Hidden Figures no more. What do you think it would mean to be a human computer? How much practice do you think it might take to do the calculations accurately and quickly? Of course, when it comes to NASA space missions, it is important not only to do calculations correctly, but also be sure everyone on the team is working with the same system of measurement and therefore the same numbers, whether human or electronic computers are doing the calculations. For example, a person in Australia or Tanzania is probably measuring distances in kilometers. So that person might say that the distance to the moon is 384,400 kilometers, while someone in the United States might say it is 238,855 miles. These are two very different numbers, and it could be disastrous to mix them up. In fact, a costly mistake of this type did happen in 1998. In December of that year, NASA launched the Mars Climate Orbiter, which carried scientific instruments used to examine the atmosphere and surface of Mars. Don't worry, no humans were on board. When the orbiter arrived at Mars, it was supposed to orbit the planet, but instead it continued to descend 105 miles lower than expected. The heat and friction from being too close to Mars caused the orbiter to burn up almost instantly. What went wrong? Well, two groups of scientists working on the orbiter had used different units of measurement. One group used the International System of Units, and the other used the United States customary units. They mixed up the units. This seemingly simple mathematical error cost NASA $655 million. That's a lot of money. Today, NASA tends to use the SI, or the International System of Units, for most of its missions to avoid problems with mixed units. This means the entire world knows what these units are, and NASA has conducted many successful missions to space since the orbiter's disaster. So, if you ask a NASA scientist the average distance to the moon and the calculations they use today, either by computer or by human calculation, they would likely say 384,400,000 meters, or 384,400 kilometers, but definitely not 238,855 miles.